In the diagram, equilateral triangle ABC, what is that? It's this one, right? And regular pentagon ADEFG is this one. They are all inscribed inside the circle. Now, this circle's perimeter, what they meant is circumference, is 165. So if you go around this 165, and you must be bothered by the fact that the circumference doesn't have pi in it. It bothered me too, but that should bother you only when you want the radius to have a rational number, such as 2 or 3. So if you have a somewhat clean number for the radius, yes, you will get stuck with pi for the circumference. But if the circumference is a number like 165 without pi in it, then you get something divided by pi for the radius. So somebody has to get the mess of pi, or should I say the honor of holding pi somewhere, either in the numerator or in the denominator. And in this case, the radius will get that because the circumference doesn't have it. But we don't care because they gave you circumference and they are asking you, the problem is find the arc length CF. They want you to find this, which also has nothing to do with radius. So we can do this problem without dealing with radius at all. So we will solve this problem without involving any pi in it. You will see how it's done here. What you have to first realize is that this of the circumference of 165 here, if you take a look at this triangle, it will divide the circumference into 3 equal pieces, right? Here, here, and here. How do you know it's 3 equal pieces? I can see there are 3 pieces, but are they equal? Yeah, because it's equilateral. So, how big each one be? How long would it be? Well, it's 165. I'm dividing by 3, so each one is 55. So from here to here is 55. Okay, very nice. We can live with that. Now let's take a look at this pentagon. Pentagon obviously will divide the circumference into 5 equal pieces. How do we know it's equal? Because they say it's regular. So if you divide this 165 by 5, you see each one is 33. This would be also, I meant here, I'm talking about pentagon here, right? It gets messy, so let me write it again. That's 33, and the second segment of pentagon is also 33. Okay, so I have this question for you. I will write in red here. How long is this? Obviously, it's going to be 66, because there are 33 and another 33, right? Of those, I think that was well, it's 66, right? So I will erase that. And from here to here is 55. Should I make it red again? That's 55. So I think the answer should be clear to you now. The arc length from A through F was 66, the old thick red one. And this thick red one I show you now is 55. So this CF that I'm looking for here is the difference. It's 11. So the answer ends up being 11. It's messy here, but now you can see here. So in summary, this is a circumference without pi in it, but it didn't bother us because we realized they gave you circumference and they're looking for a part of circumference, the ratio of the circumference. So if I solve this problem without this 165 business and just using these here, suppose they told you the circumference was C, right? And this length that I have here from here would be C over 3. And if I use the pentagon, and then each one is C over 5, right? So in that spirit, the circumference or the arc length from A through F is just twice of this. So you have 2C over 5, and you'll be taking out this the arc length of AC, the one formed by the triangle, you see, this one here. So in that case, that would be, as I said, is C over 3. So that's the answer here. If I want to, I can find the common denominator 15 here, right? And this becomes 6c, and this becomes 5c. So the answer becomes c over 15. So this length between these two vertices of a equilateral triangle and regular pentagon is 1/15 of the circumference. In this case, the circumference happens to be 165. So you stick in there, and then you get 11. So that's how you got the answer. So if you realize this fact here, then you can apply this to any cases here. If they come up with different numbers, no problem. Plug in, and you get the answer. So next time you face this type of problem, then you know it's a c over 15, circumference over 15. And now here it is abundantly clear why not having pi didn't bother us at all. And also you should know that all these things are just dealing with cutting the circumference into equal pieces, into say 3 pieces, into 5 pieces. So if there were some other weird polygon, no problem. Just divide by that, and you just got to count how many segments it took up. In other words, in this case, it took up 2 arc length, 2 sides of the polygon. So if you got some weird polygons of 11 sides and all, no problem. Just start counting, and that's all there is.